Hello, this is Richard Esplin. We are live, I believe, episode 81 of Tech Talk Live. It's December of 2014, and joined today by our guest, Christopher Delp with NASA, and we're excited to have you join. Christopher presented at Summit in October, and I feel very badly, but his mic didn't work. So the recording didn't work, it's not posted, and so he graciously offered to share again his presentation. It was very highly reviewed, and I think it's a really interesting example. We don't have a lot of systems engineering's applications of Alfresco, and it's a little different aspect of content and modeling than I was used to, so I found it very interesting. Before we start, a handful of announcements. Hopefully I don't get in trouble for being too early, but most of you, I hope, have received an email, the Alfresco customers, about the Enterprise Edition release, which is fresh off the presses. 5.0 is finally out, so Alfresco 5.0 is available this morning, so I'm very excited about that. Community Edition is coming. It might be available. It might be within tomorrow. I'm not sure. I've got a bunch of emails about it I haven't caught up on. So we also have next Tech Talk Live will be January 7th. We're going to talk about upgrading to Alfresco 5.0, and we have an interesting panel of since it's fresh off, since it's brand new, not a lot of people have done an upgrade yet, but we have our internal systems upgraded, so we'll have our team that did that on to discuss concerns and issues and things you should know about. And then on January 16th, we're having office hours with the engineering team, so that'll be a great way to proceed, a great way to catch up. Oh, looks like I didn't have you looking at me earlier. I had it locked on Chris, so apologize for that. So yes, I'm Richard Esplin, and I'm broadcasting from our San Mateo offices. And Chris, where are you based, Christopher? Oh, I'm not hearing you. Did we have audio disappear? Oh, there it goes.
Is it back? Okay. I'm out at in Pasadena, California, at the Jet Propulsion Laboratory.
Excellent. And would you mind introducing yourself a bit and give us some background on what you do for JPL?
Sure. I'm a systems engineer on the Europa mission, or the Europa project, I should say. We're not officially a mission just quite yet. The mission is to send an orbiter to, or as we call it, a flyer to the to Europa to investigate the possibilities of life and the building blocks of life. I'm leading a team that's building a model-based systems engineering environment. So this team is building a software platform that can support end-to-end the use of engineering models to specify the mission.
Excellent. Is your background as a software engineer or in the hard science side of things?
Interesting question. My education is in systems engineering, but I've spent most of my career working in software. I have held other roles earlier in my career, so it's an interesting mix.
We have our first question from the audience on chat. How do I work at JPL?
Well, the easiest way to get a job at JPL right now is to have just graduated college. So we hire a lot of early career hires, fresh outs. So if you're just coming out of college, that's the easiest way. But I think we consider all comers, so it's always a good time to try to get a job in the space program.
Excellent. So I know your abstract to describe this topic is very long because it's a very interesting topic. Can you give us an introduction to how you use Alfresco?
Sure. So, and this is actually a pretty important component to the talk because the Alfresco audience is a little bit different than the audiences that I usually talk to. We use Alfresco a little bit unorthodoxly, if you will. We have well, so let me start with the problem statement. So the challenge that we face in systems engineering is fairly similar to what mechanical engineers faced a few years ago when they migrated from hand-drawn, pencil drawings of blueprints for components to full 3D CAD modeling. So the general objective is to move out of the space where we have these disparate engineering technical artifacts like documents or spreadsheets or hand-drawn blueprints or what have you, into a space where the entire system can be represented as a computer model. When the CAD engineering folks went through this, obviously this is a big paradigm shift from kind of a traditional artifact-based system to having the entire representation of the mechanical system as a 3D model. And the systems engineering has similar challenges. So traditionally, systems engineering products often look like documents or spreadsheets, PowerPoint slides, diagrams, big Visio bedsheet type diagrams. And these artifacts traditionally exist in an isolated fashion. I think systems engineering is one of the last disciplines in engineering to come into this space because of the difficulty in representing what a system is. For a mechanical system, what you draw is what you have, right? If you have a hinge, you draw a hinge. It works like a hinge. It looks like a hinge. Similarly with a planet or a spacecraft or what have you. But systems engineers tend to identify functions and functionality and describe the behavior of those functions. So they deal with a lot of abstract stuff, and it starts to kind of blur into the area of software engineering. Software engineers have to do similar kinds of things. How do you represent logical behavior, constraints, things like this? So it's a little more challenging. More recently, the thing that kind of kicked this off was the occurrence of, or the invention of the systems modeling language. So this is a language that was implemented as a profile on top of UML. I think because it most closely matched a lot of the artifacts. Block diagrams of components and interfaces and functions and all this stuff that's struggles for a tangible, intuitive representation that you might get from a physical representation. So moving from that space into where we're at now, we started using SysML to model systems at JPL about 5 years ago with a lot of success. We've modified it with a couple other aspects. We use OWL-based ontologies to do formal reasoning on the system, so to do analysis. And then we use we generate documents and other artifacts from the model so that we have this authoritative source of information. So the challenge that we ran into is all these things work great as prototypes, but how do we scale it into an enterprise? Europa has a couple hundred people right now. As we continue to grow into a mission and start building a spacecraft, we're going to have hundreds more. Obviously, the data volume is going to shoot through the roof, and we needed something that had some scalability to it, and we also needed something that we could write web applications against, so that we could engage people who work with the system model but that aren't so-called CAD engineers. They're not the detailed tool experts. They needed a lighter weight, higher fidelity medium where we could engage customers of systems engineering products as well as systems engineers and other types of engineers that weren't necessarily intimately familiar with the detailed work going on in one area but still needed to review it, comment on it, read it, reference it, etc. So the general problem boils down to having an authoritative source of information. And the problem with a document is that there's no way for me to go into a Word document and say this number here in this table that represents the mass of this thruster is for all the world to reference the guaranteed mass number of that thruster. We talk a lot about mass, by the way, in the space business, because mass is basically money. It's very expensive to get things into orbit, so and there's obviously physical limits on what we can actually put into orbit. So When you hear me talk about mass, think economics at some level. And so we need to know these numbers, right? And it's not just about tracking documents anymore. It's about tracking these individual representations, the specification for this component, the specifications for the interfaces on that component, the things that it connects to. So we end up having this kind of named graph representation of the spacecraft, if you will, where all these nodes are identified and related. And we need to parse and analyze these things both to generate artifacts that engineers and other human beings can still digest, as well as to do this formal analysis. So
now is the system, so the system you're modeling, is it just the spacecraft, the flyer, or is it the entire system that creates the flyer and gets it into orbit?
It's both, actually. So we model both the project system, if you will, as well as the mission itself. So the spacecraft, the components on the ground that talk to the spacecraft, the software components that do the ground-based control of the spacecraft in flight. We model the entire thing, and each piece of that model, you know, has a criticality attached to it, and both in the sense that when people have to go looking for this information in multiple sources, or they have to document it in multiple sources, it's expensive, it's time-consuming, it's tedious overhead, as well as making sure that, I mean, we have to make sure that each specification is right and cared for and configuration managed so that we have that reference for what we're building. So the systems engineering model essentially represents the requirements. You can think of it as a giant constraint network. Other models, obviously, that we have, like CAD models, for example, or navigation models, or power models, or other kinds of analysis models, need to hook into that stuff. So how we're using Alfresco is we've taken the metadata facility of Alfresco, and we basically are using it as an object-oriented database. And so it's metadata about nothing, basically. So all the model is trapped in the metadata. There's no documents, if you will, at the end of it. There are values. So in one respect, if you're familiar with Alfresco, I guess you could think of it as a giant metadata model around documents that are like a single number or a single name and property description or something like that. And we did an extensive... Go ahead.
Are they contentless nodes? Are they modeled as contentless nodes, or where it is just metadata, or do you take a value and add it as a text document?
No, we don't actually add the the data as a text document at the moment. It's something we've considered, but for the most part, it's basically a really gratuitous package model. So we've used primarily the packages and all the property definitions. So we're treating the packages as objects, basically. And using the aspects to perform typing and stuff. So effectively, if you're familiar with ontology, we've effectively are using the metadata as an ontology modeling capability. We did an extensive trade study behind this. Obviously, there are a gazillion solutions in the NoSQL space, and obviously SQL space. There's a number of solutions in the web application framework space, like Django, Ruby on Rails, things like this. And I think our initial objective was to try to use semantic web technology. Unfortunately, semantic web technology lacks a lot of the fundamental infrastructure features that, that you find in Alfresco, for example. It doesn't have element-level versioning. It doesn't have access control, notification, all these basic capabilities. It does a really good job of formally representing the model and doing reasoning and so forth. But and we found that actually to be true for most of the NoSQL solutions. There's not a lot of kind of general purpose application support for using them. It's probably changed some since we did the trade study. So the trade study boiled down to web application frameworks like Ruby on Rails or Alfresco. I should mention also that we looked at enterprise wikis as well, like XWiki and Semantic Media Wiki. My personal opinions aside about how much I hate wikis, they just didn't have the wherewithal. They just didn't have the enough formal structure to build what we needed to build. So like I said, it boiled down to web application frameworks and Alfresco. And the big difference there was that with web application frameworks, we could probably get them to do whatever we needed to do, but we had to build all of it. So it boiled down to cost, whereas with Alfresco, we were able to get it up and running within a day. We had a working platform, and we could start building applications on top of it. And it basically had all the same features as a web application framework, but obviously a whole lot richer, right? Indexing out of the box, all the versioning and access controls, LDAP syncs. There's just a ton of stuff we just didn't have to mess with. And that was good for us because that's not really the business we're in. Obviously, we're building a spacecraft. We'll build software that we need to enable that, but it's not our primary objective is to invent this new mechanism. So that's how we're using Alfresco in a nutshell.
So it sounds like you're using Alfresco in many ways to be a graph database, but you like all the infrastructure around it to handle the user interaction and the versioning and the comments. Is that a fair assessment?
Yeah, we basically need a graph database as the back end, but we need to write applications against it. And at the time we did our trade study, there just wasn't a solution that had both options, except for things like Ruby on Rails that have an object relational mapper. But then again, it was, like I said, it's more effort to build that up. Yeah.
How long ago did you do your trade study? And question of what version of Alfresco you're using, enterprise or community, how many objects do you have in it, all that sort of stuff?
Ooh, we did the trade study over a period of about 4 years. I would say we wrapped it up about a year ago. So in software time, that's about 1 million years ago. As far as versions of Alfresco, we're on 4.3e, I think, and I don't know. We're using both community and enterprise. Obviously, we have a lot of researchers at JPL, so we maintain deployments of both, so that smaller scale efforts can use community and experiment with it and whatever. But for Europa, we're in the process of deploying our enterprise deployment. The number of elements, boy, I don't have that number off the top of my head. I would say in terms of nodes, we're easily past millions. The models we have are fairly sophisticated, and they're fairly early too. The biggest reason that we bought enterprise was the clustering capability. I'm very concerned about being able to scale this thing out into oblivion as we go from a couple hundred people to 500 or 600 people, and the amount of data that we're processing and dealing with just skyrockets. And then, yeah.
So do you expect to end up in the tens of millions or the hundreds of millions?
At least, I think. It's a little difficult to predict because we're not entirely sure. I mean, the system model, if you will, is only one model of many models, and it's not really clear when it will be done, like how big it will be when it's done. I think in traditional space, this would be a huge pile of documents, hundreds of documents, Visio drawings, things like that, as well as test data and stuff like that. So I think you'll see when I demonstrate the application what the potential is for scale here. It's virtually unlimited, but we may also do things like archive part of an auth or federate it into 2 repositories somehow. It kind of depends on the life cycle and the need to maintain certain parts of the model long term, stuff like that. So those are things we're in the process of figuring out. But suffice to say, I expect it to be a non-trivial size.
Yeah, sounds like it. Especially considering you're already in the millions and you still need to triple your team and actually build the thing. So the couple questions before you go dig into details. Hey, how long have you been using Alfresco? Have you had to manage an upgrade of your content at this point, and how did that go? And the second question is how you're doing versioning if you're only storing metadata.
Well, I'll answer those in reverse order. The metadata is automatically versioned given certain aspects in Alfresco, along with the document, which in our case we just don't have a document in there to be associated with the metadata. I'm not the one that did that specific part of the implementation, but I do know that it works. So I think it's just built in Alfresco. One trick we did have to do is that Alfresco doesn't version relationships, so we had to reify the relationships. So we basically have nodes that represent first-class relationships, and those get versioned as well. So we have a version of the entire graph. So we had to hack it a little bit, and but we do have some requests in to update the content model, facility in Alfresco so that it automatically versions relationships and things like that. And the second question, have we had to migrate our data between versions? No, not yet. We've only done 4.3.x stuff, so we haven't had to do like the 4 to 5 data migration yet. I'm sure it will be exciting. But
and you're using 403, not we don't have a 4.3, so it's a 403 or 423.
423. Whatever the latest version of 4 is at patch level E.
Yep, okay. That makes sense.
Yeah. So is that it for questions?
Yeah, we're really interested. I think the rest of the questions are going to come out as you show the project. It's things like, what does the project look like? Where is it available?
Sure. Well, and I should mention also too that in a very unusual circumstance, we've been given permission to open source all of the code that we're writing. So we have a github.com site where you can go and get all this code. We obviously, I think I put up a thing on the Alfresco community page too, where you can get the AMP and all that. So feel free to deploy it if you want to try it out. So I've modified my presentation a little bit from.
I'll need to make sure to add that GitHub link into the show notes on YouTube.
Sure. In fact, if you Google open-MBEE, it'll be the first one that shows up. So the more general idea behind the open sourcing it is that we have an open end-to-end model-based engineering environment. So we're going to have code there that has our web application, our Alfresco AMP, also our code that works with synchronizing Alfresco with the triple store to do formal reasoning. We have a constraint solver there, so if you're familiar with AI-based planning and scheduling constraint problems, there's a constraint solver there you can mess around with. So at the end of the day, we want to have a suite of open source software components there where anybody can deploy a completely model-based engineering platform. So other committers and contributors are welcome and encouraged.
It's funny to see 5 people write in the chat at the same time. Whoa, this is wonderful! You can see about the time it takes to type the Google address, the Google search.
Yeah. No, we picked a unique name. It looks like we got lucky.
Open-MBEE at github.com. So.
Yep. All right, so I'll jump into the presentation now. Let me turn on the screen share. Let's see. Okay, I should be screen sharing. Okay, so this is, I've modified the presentation such that it now appears in our web application. And there's a reason that I do this, not the least of which is that I insist that everybody on my software development team eat our own cooking. As systems engineering is fundamentally a big communication problem, which kind of follows from what I was talking about, having to have this interoperability between data about the system and so forth. And so a big challenge we've had with getting model-based systems engineering injected into the organization is that the ability for the systems engineer to present and communicate the information about the system to large audiences and make it accessible and readable by human beings is a big challenge. If you've ever used any kind of engineering CAD tool, from Simulink to AutoCAD, NX, Magic Draw, the UML tools that SysML is built on, they're all heavily centered on an engineer sitting at their desktop solving a very complicated problem. And the typical use case is they do all this deep, technical, involved work solving this problem, and then the channel that they have to communicate that work is something like Microsoft Word or PowerPoint, right? Which is just, it's so disconnected from the raw material that I think much is lost, and it's a huge amount of overhead to link these things up. You know, you build a simulation of how a spacecraft, you know, flies in orbit and how it consumes power and when it takes science data and all this stuff, and you take that simulation and then you take a couple screenshots from it and paste it into PowerPoint. I mean, it's a huge loss of fidelity, right? There's no interactivity or communication for the broader audience. There's no way to just engage them directly. So what we've built on the web application is based around a concept we call views. So the idea of a view is that it's abstracted a little bit from a document or a PowerPoint slide or something like that. It's just a window, if you will, into the model of the system. And the application has a couple neat features around this right away that I'll show you. So this is my presentation, and you'll notice that I'm going to be able to step through it and show you the different kind of slides, if you will. This information is all rendered from the system model, and this is what we call the audience participation mode. But when I click
this... Is this UI written, what technology do you use?
This is built on Angular. So that's another trade study we did. We looked at, we wanted to have a completely client-side JavaScript application. So we looked at Ember, Angular, a few other technologies. We looked at Polymer, some of these more exotic future HTML features, and we settled on Angular. And the reason, obviously, that we need to do this is that we need to an MVC backend for the client so that we can store model-based representations of the system model and interact with them in a manner that's a little richer than data, than a typical kind of form-based.
And are you pulling the content out of Alfresco through CMIS or the REST API or through custom web scripts?
So we started with CMIS, but we moved to an API that we've written on top of Alfresco's API that we call the MMS, which is the Model Management System. So we needed a little more sophisticated interaction with the graph in certain areas, but it is running on top of Alfresco right now, So it's an Angular application with a few other JavaScript libraries and such. And like I was saying, we have this audience participation mode, but then I can, if I'm at my desktop, I can switch to this document mode, if you will, and I can just scroll through this whole thing like it's a regular document. And we have different style sheets that we use to control how each are rendered. So the objective here is that if I need to look at something as a document, I can look at a set of views as a document. So these are the views over here. But if I go in front of an audience, I can present the same information, and I don't have to do any extra work to synchronize or what have you. I can just present it, and it's formatted for an audience. So it's a huge, relief on the engineer who's spent all this time in school learning all a DocuJock or a PowerPoint Ranger just to get their work done. They can focus on the technical work and very easily come in and present it in this manner. So the model is actually embedded in this text. So if I click this box here, you see here now that I actually have model elements that represent each of my team. But these people here are just plain text. So These are actually, this is a technique we call transclusion, or to the layperson, cross-reference. So what's actually happening here is the Angular app is retrieving this piece of data from Alfresco and dereferencing it in place using a custom HTML tag, similar to how Polymer works, if you're familiar with that. So you can see over here, this is the metadata view, if you will. So this tells me about this view here, my Open MBE summary view, and it tells me when it was last modified. And you can see these same tags in here, these cross-reference tags in this view. And then if I go and I click on myself, you see my entry here in the database, and I could go and I put a comment in there. I'm pretty proud of myself, whatever. You can see when I last changed my name and what my unique ID is and all that kind of stuff. So what ends up happening here is that we can now enter data into the database and interact with data in the database, and we don't have to write any custom web forms or any special kind of workflows. We can just build engineering documents like engineers build documents and pull information out of the database and in the model. And there's no special activity or special IT function required now to build up this structure. So I can add data here. I can come back to my view, and I can see, oh, well, I didn't add Klaus here for some reason. So I can come in here and I can cross-reference. And actually, there was a reason I didn't add him. I think there's some bug with his data, so I'll try to add him again. Hopefully it'll work. Not finding him. Let's see. Oh, maybe he's not in there anymore. Oh, that's right. He's not in there at all. So I didn't just not even cross-reference him. He's not even add there. So I can add him now. And come in here and I can just create a new entry in the graph. And now I find him, and I can just pop his name in there, and now he's cross-referenced. And I can save that. And now when I go back to my view, I see him in there. There he is. So he's not. So now I can come back and I can take him out of the simple text. So this is a very simple example, obviously, of how we keep track of these references in the model. Obviously, I could do the same thing for a mass value or whatever I need to do, and it can get a lot more sophisticated. But it gives you a general idea of just how we keep track of this authoritative source of information. So I've only got one Klaus. There he is. Hooray! And
Very
similarly,
cool.
I can do comments in the same way. So I added this comment earlier. I can see why isn't he in the model. So I get the same inline commenting mechanism you get in Office products, and I say, oh, yeah. So we can still get this, editorial feedback and so forth built right in, and show and hide it with ease. So that just to kind of put the frosting on the discussion of how we're using Alfresco. That example gives you kind of a nutshell how it all works. So I think in these slides I talk a little bit about some of the issues we had with our customers versus yeah. So we, like I mentioned earlier, we had some adoption challenges, and so just to put the frosting on that, the big difference for the customers of systems engineering products is we couldn't really radically change their existing work products. We had to work within how the organization already functioned, which was a document-based set of interfaces. And there's a host of challenges that we went through with practitioners as well. I think I've kind of highlighted those already, but you guys can read through the slides. Generally, my impression is that this is a lot more of a software-oriented audience. So I think when I did this at Summit, I kind of shifted the focus of the talk a little bit to be more about the software. Not everybody at JPL is super enthusiastic about software. We have a little bit more of a schizophrenic culture. We build hardware and we build software, so it was very interesting.
And you launch them all to foreign planets. So cool.
Yes, definitely. So let's see. So basic concept. So the basic information concept behind this, that the way that we're building the meta model in the metadata repository is based around this idea of having models, which are basically a representation of the data of the system, views, which are, like I said, windows into that, and viewpoints, which are the rules for how the model is viewed. So it's kind of, if you're familiar with MBC, it borrows a lot from that concept, but it also borrows from this idea of two-way communication. So the model is the representation of the architecture of the system, whatever that is. And in model-based systems engineering, it doesn't have to be a space mission at all. It could be a safety device for a baby, or a bottling plant, or whatever. But the viewpoint represents the point of view of the stakeholder. So the idea is that there's some independent set of rules that a stakeholder expects to see for any given representation of the system. And the view just displays the model according to those rules. So the view and the controller rules are stored in the viewpoint, and the view is the representation. So what you actually see here in this picture is the view of this viewpoint of the model. So each of these are views. They all have their own viewpoint. And the model that we have in here is obviously not that sophisticated, but it all works on the same principle. And for those of you who may or not be familiar, that's based on the ISO 42010 standard, or for those of you who know it from longer ago, the IEEE 1471 standard for systems architecture. So this diagram here shows the larger architecture of the whole system. So we have this, the idea is we have this rich model editor. This could be Simulink or Magic Draw or any kind of SysML tool. And then we have this web-based editor interface to make that complementary experience for the systems engineer. There's nothing in the concept that requires this not to be a web application, or that these two need to be separate applications. It's more the understanding that the functionality needs to be separate. We have an information exchange component. So we currently use an Oracle service bus that we have already provided to us to do this mechanism. But in principle, this could be any kind of mechanism like that. The model manager and the model repository, this is the API that we've written against Alfresco, and Alfresco is part of what we're using for the model repository. We also have a database that was built here called the timeline database. It stores large quantities of basically time-stamped data. Obviously, time is important to us working with relativistic effects and so forth. And then we have a component called the model analyzer. This is where we do all the formal reasoning, model checking, constraint solving, and so forth. And then we have external services interfaces where we integrate other tools. And we have a development environment that comes with this as well, which you guys will probably find more interesting than most audiences. The general idea here is that we want to be able to completely streamline the ability for anybody writing an extension for this architecture, so that all they have to do is code it up in the development environment, and they can automatically compile it, build it, and push it out to a test server of some kind. So each of these components has an extension point built into it so that you can write your own extensions. We have a lot of very creative people here, and particularly when it comes to web-based visualization or analysis, we want people to make it as easy as possible for them to tie in their visualizations into this web application or onto the services for doing analysis. We want to streamline that process as much as possible. So we use an environment built on Jenkins, Grunt, Maven, Artifactory. For those of you who may not be aware, JPL actually piloted the Amazon GovCloud, which is a version of Amazon that is ITAR protected. So we actually run all of this on the GovCloud. In fact, this app is actually running from GovCloud on Amazon right now. We use Scalar to, yeah, it's extraordinarily cost effective. So we use Scalar to manage all of the GovCloud instances that we have. We have an on-premise cloud that we're building using Nebula as well, so Scalar manages both. And we use Salt to do the configuration management. And we have workstation-based deployments, so people are using GovCloud machines on either Linux or Windows to run various engineering tools, Satellite Toolkit, Medelica, Mathematica, Eclipse. And then we have our cloud servers that store the model repository and the timeline repository and ontology and so forth. And this whole thing is wired together so that we can fairly quickly deploy test instances, development instances, and do intentional production instance updates as well. Let's see. So I have actually made a video of what I usually show as part of the live demo. This shows, if I can find it, this shows, where did I put that? There it is. So this video shows the latest in what we've added to our application. One of the things that we've added to, oh, that's not the right one. What's going on here? Hang on. Bear with me just one moment. QuickTime issues. Yeah, that's the one I want. There we go. Okay, I just clicked on the wrong one. So we wanted.
One question while you're finding the video is how much time did all of this take? How many engineer hours have gone into building these tools?
Well, if you count all of the prototyping that we've done over the last 5 years, it's quite a number of people have worked on this. I don't know if I can give you an exact number. Our current team, we have probably about a dozen people working on various aspects of this. The component I'm showing you right now, we've built over the last year, the web application and this branching emerging piece. So it's relative to the sophistication of it, I would say it's been pretty low cost. I mean, obviously we've used a lot of existing open source capability, and that's really, we've tried to emphasize, we've tried to minimize the novel amount of software development that we have to do and maximize our use of existing open source capabilities.
That's a wise way to do it.
Yeah, that
and I think the responses. Sorry,
go ahead. No, go ahead.
The reaction is that so you spent a few years, 3 or 4 years researching, and then you built all of this in a year. Like that's pretty impressive.
It is actually. It's not always viewed that way, but yeah, I think it's the right way to do it. To fund the architectural prototyping and systems engineering part at a low but important level, so that you can have that time to do the research, to figure out, to do those trade studies, to actually, we built 2 architectural prototypes previous to this. The web application we built against Sesame, a triple store technology, and the document and content management generation component we built on Django. And being able to do that was really key, I think, in understanding how the trade study ultimately ended up working, because we had real data and experience with what is it now going to take to solve this detailed problem within this architecture prototype. Does this technology actually have all the answers? So you need time to get smart about what you're doing, and you have to have that time to do that experimentation. So, this piece.
You need time to get smart about what you're doing. That's a quote that needs to go get repeated.
This stuff is complicated, and you can't just jump into it overnight. What's interesting behind that is that there were about 3 or 4 different projects that I've worked on that have led up to this. So it took quite a bit of coordination to keep everybody kind of tied together and make sure we were progressing towards this result. We have a grassroots community here that we've started called the Modeling Early Adopters. So we've kind of harnessed the power of the open community here to keep a trajectory in the direction that we needed to go between these disparate projects, Um, that was a very unusual circumstance. It's hard to do what I said. In most organizations, they want results today. They don't want to spend a few years tinkering with something, getting smart about it, and see if it actually bears fruit. That is one of the luxuries of working at a place like JPL, is that we do have more of those opportunities. That's part of our role. That's part of our contribution to the country. So.
Well, and you can't exactly change tool sets in 10 or 15 years when your lander unexpectedly is still producing good data.
Yeah, no, yeah, that's true. Once you get into operations, it's very difficult, particularly with software, to keep things maintained. I mean, you guys are familiar with the Voyager mission. That's been in operation for several years, to say the least. Software has software has gone through an extraordinary amount of changes between when Voyager was launched and the way it works today. But Voyager's ground system that collects all the telemetry and sends commands and stuff still has to function. So they've had to refactor it and reintegrate it while it's out in space over and over and over again. So yeah, that's definitely a very challenging problem. So this last piece I'm going to show you shows how we've built kind of a GitHub-inspired branching and merging capability into the web application on top of Alfresco. So we've built branching into Alfresco, if you will. And this application shows you how we're going to create a task, and a branch is going to be created associated with the task. And then we're going to show you how one of our engineering tools that's integrated with Alfresco using JMS is going to synchronize the data in the engineering tool with the database in Alfresco and redisplay it on the web. So I've got my root task here, which is build the mission. I'm going to create a subtask, and it's not a very exciting task. I'm just going to make some changes, and it's going to show up here. And what's happening here in the background is Alfresco is creating a workspace. The workspace is empty in the beginning. It tracks changes against the trunk, not copies or clones of it. So I go in. Let me stop there for a second. So what's happening here is whenever I make the workspace, I go into the web application, and the web application functions exactly the same in each of the branches. So I'm coming into this document, I'm actually seeing it like it's the normal document in the workspace, but when I start to interact with it, the changes are going to be stored in the workspace. So I go into this document, I've got a table of subsystems with some masses. I go back to Magic Draw, which is my SysML tool, and I start up the JMS session. So this is using REST calls to send data to Alfresco, and it's using JMS, ActiveMQ, Apache ActiveMQ, to send changes from Alfresco back to Magic Draw. So I come in here. Apparently, I was off on the mass. It's 10 kilograms more than I thought. So I'm going to hit close. It's going to save it into Magic Draw. So my propulsion subsystem is now 60 kilograms. And I reload the web application. I see now that it's 60 here in the table. So this demo is very exciting for those of us who use these tools, because being able to interact with the data at this high fidelity is quite a convenience. So apparently I forgot my battery. So here I'm actually adding a model element called battery. I'm going to go into the web application, and I'm going to click on the documentation field of this table, and then you see it brings it up in the element inspector here. So I'm going to make a cross-reference to my battery now, because it's automatically been added to the database for me. So there it is, and I click on the name, and now when I hit save, the documentation field is going to update here, and I'm going to see my battery show up right in the middle. So there's my battery. And then apparently that's not enough. I think I have another mass number that's incorrect. Yeah, my power subsystem has too much mass. So I'm going to select that value, and I'm going to go into the editor for that value, and now I'm going to change the property value from 50 to 6 or 9, which is a substantial savings in mass. Apparently, miniaturization of batteries has caught up to us. So, but you'll notice that it changes in the tool immediately. So, and all of this is happening without interfering with the baseline configuration of my spacecraft model in the trunk of my database. So I'm done with my changes now, so it's time for me to go merge. So I'm going to pick these two options. So I'm going to compare my make changes to the parent task, and I'm going to merge them in. I have my little shopping cart kind of interface, if you will, so I can click on each of these and it shows me the difference between the trunk and the branch. You can see my mass changes, my battery addition, so on and so forth. So I could decide, okay, I assigned this guy this task, he did it right, so I'm going to accept all these changes. Wait a minute, maybe I'm not quite sure about it yet, so I'm going to undo that, and then, well, maybe, yeah, I'm going to come back and accept them after all, and then I'm going to hit merge, and off I go. So, and you see over here the containment tree that shows all the components in the power subsystem and the changes that occurred as part of that.
Douglas mentions how impressive that is. It seems lots of people say this is really cool, and one of the comments in chat is how the value of using open source tools when you don't know how long this is going to be in production, to know that you are in control of that code and it can outlive your vendor, and you have options to maintain this. Most people wouldn't, but you'll need to. There's a really high chance you'll need to.
Yeah, no, that's definitely an issue, I think. And in fact, I think traditionally for mission critical software, JPL has always built that stuff in-house. So we've usually owned the code because, yeah, we can't rely. Obviously, whoever built a ground system for us for Voyager would most likely be out of business by now, especially in the software industry. So open source code is very popular at JPL because people do have that ability to feel like they own it, that it's going to be around, that if they get into a really bad situation, they won't have to deal with any kind of vendor challenges. So definitely, that's a big plus. And by the same token, the reason that I pursued open sourcing our stuff, it falls into the same logic. It needs to become part of the larger software community and be something that we can handle. And even if we're not able to, for some reason, maintain it as much as we have in the past, hopefully the community will pick it up, and it can be something we can share the burden of maintenance on and so forth.
Excellent.
So, any other questions? I think that's about all I have.
No, the conversation in Skype in chat in IRC is just about how it is a very interesting project. I find it fascinating. It's neat to see the flexibility of the repository. My background is office collaboration, and you get in the idea of let's send the marketing document around, but it is just a network of content, and so you have a network of metadata bundles with mass and batteries and things. But the fundamental problem is the same, and it's also interesting to see that the value that the user level, like you said, authentication and security, a lot of these things you don't think about in a graphing database, but you do think about in enterprise content, and so you're leveraging all of that infrastructure for your graph.
Yeah, I think usually graph databases, it seems like the predominant use of graph databases is to suck a bunch of data into it and then do some kind of analysis and visualization about that data. I think that's why we didn't find a lot of options for doing this where we actually want to build the graph from the beginning. We don't want to try to figure out what it is after a bunch of people write a document and go through all of that headache. We just want them to create it that way right from the beginning and still be able to do that same kind of rich analysis. And I should mention, too, we actually generate hard artifacts from this, like PDFs and whatnot, and it's really handy, obviously, Alfresco, I think we've used a modified the rendition service, so we can we actually pump out a PDF of the document. So you'll never deprive the government of its documents. So we still need to be able to give somebody, in certain cases, a hard artifact that they can walk away with it. And we just want to know when we give them that artifact that it has, that we have a lot of confidence in it.
Yeah, absolutely. So I know you have to leave in about 4 minutes. Sujay is really interested how this information looks from the Alfresco interface. If you would be willing to show us a little bit about the same power subsystem on the Alfresco side or something similar.
Yeah. I don't know if I can find this particular model, but let me
it doesn't have to be exact.
I can see where I had Alfresco open. I thought I had it open. There it is. Yeah, so if I go into the repository in share, then I see, let's see, sites. Let's see if I can find it here. This particular one. Actually, I think I can just go here. Oh, yeah, but I can't see it from the document library. Hang on, I'll find it. Oh, that's weird. It's sort of.
Darkstar says it's going to take him a little while to digest what he just saw.
Yeah, it's yeah, it's definitely I think from the conventional ECM space, it's not what you typically would expect to see. So here's what it looks like from in here. I'm trying to remember what. I can go into any one of these, I guess, and you see. So these packages just represent the nodes, I think, and then if you like go into one of them, then you can see the properties here. Maybe, yeah. So there's like our system LID, the name and the unique ID, the creation date, the tags. There's the name on that one, the documentation. So I don't think it looks any different than if you had your own custom metadata. I don't know that we ever recommend. I think you can edit the property values and stuff from this window, but
yeah, it's interesting as you were browsing through the sites to see that you also use Alfresco for a lot of your internal collaboration. Is there any plans to tie those internal collaboration documents directly to the parts of the model that they reference?
And in fact, there is, and in fact, that's one of the what turned out to be kind of an emergent benefit of using Alfresco is that we're no longer in this space where we have to have one repository for conventional file artifacts and whatnot, and the system model. We can now have them both in the same place. So if we need to, we can say, well, this actual piece of file data here is actually related to this set of variables or something like that. So we can make model-based relationships to things that aren't traditional model elements, a MATLAB script or something, but it's all unified in the repository.
Here's the circuit design for that battery, connected together.
Yeah. We can tie in any conventional artifact, so it's much more kind of open world, if you will. It's much more flexible, which is good because systems engineers, I mean, it becomes a value proposition too. I mean, not everything needs to be modeled. Some things just aren't worth the time that it takes to do it. So you want to be able to have that mix of stuff. So some of the things I was showing in my presentation, for example, there were just images that I pasted into the view because I don't need anything more than a pasted image. But I can store that easily in Alfresco along with the model data that is in there with it, and I don't have to do anything complicated.
Excellent, fascinating. I appreciate you taking the time to share this presentation. Very, very interesting. It looks like, well, we're out of time, so it looks like there's more conversation. But the It's a very cool project. It is open source. It's on GitHub. If you're interested, you can get Christopher's information. It's summit.alfresco.com, and the San Francisco stuff. There's contact information for Christopher. Thank you so much for sharing. Anything else you'd like to close with, Christopher?
No, I think I've covered everything.
Yeah, excellent. So our next event will be Tech Talk Live on January 7th. We're going to talk about upgrading to 5.0, a bit more traditional ECM conversation. But, you know, it's the back-end infrastructure. And Christopher is a very friendly guy. If you'd like to reach out and get more information on this or use it in your system modeling background projects, let him know, and hopefully we can spawn some collaboration. So thank you again, Christopher.
Thank you. All right, take it easy, everybody.
See everybody online.